So give the equation of a line that goes through two given points. So let's say that I have a point located at 2, 5. So x is 2, y is 5, and I have a point that goes through, I'll say 8, 2. So x is 8, y is 2, x is 2, y is 5. I might want to jot those points down in a table of values just for organizational purposes. So I have the point at 2, I'm landing at 5, and then I skip some, and at 8 I'm landing at the point 2. So I can see that clearly as my x's get larger, my y values are decreasing. So I do see this negative slope. The thing I need to figure out is what my unit rate of change is for slope. As x increases by 1 unit, how much does y go down by? And I can figure that out by looking at the change in my rise divided by change in run. So because this is in this table right here, it kind of organizes this work nicely. I could look at like my delta y, the change in y is as 2 minus 5. So you can see down here I'm at 2, and I go back to 5. And my change in x, you can see I'm at 8 at the bottom there, and I'm going to go back up to positive 2. So my slope ends up being 2 minus 5, which is negative 3, over 8 minus 2, which is 6, and that reduces to negative 1/2. So come back and look at the graph. If I go down 1 unit and over 1, 2, it should be on that same line. Down 1 over 2, I'm on the line down 1 over, and then I do hit that point. So I think that's a nice way to organize your work, just looking at this table of values. My change in y is negative 3, and my change in x is 6, so my slope is negative 1/2. Now that I know my slope, I need to figure out what my 0th term is. And I can do that a couple of ways, right? I can sit here and look at this table, and I can say, look, here's the first term, and here's the 0th term. And as I go down, right, every single time I progress forward on the chart, I just subtract 1/2. So if I want to, I can go back 1, 2 times, and I would add 1/2 and then add another 1/2. So my y-intercept is going to be at, it should be at 6, right? So b should be 6. Now the other way that that's using one representation, the table. The more algebraic representation we've used is we've said, well, consider one of our points and start with this, y equals mx plus b, the slope-intercept form of an equation. And I can go ahead and write down the y value. I'll use the top point where x was 2 and y was 5, and I'll say that 5 is equal to m, my slope is negative 1/2 times 2, and then plus b. 5 is equal to, this would be negative 1 plus b, and I can see if I add 1 to both sides, I do get 6. So my y-intercept is 6, and the equation of this line is y is equal to negative 1/2 x and then plus 6. Another thing that's worth noting is that if I do plug in 8, 2, or if I plug in 2, 5, both of those points should work. And it's kind of nice to just take, for example, the x from this first point, take 1/2 of that. If I take half of that, that gives me the number negative 4, or it's the negative 1/2 of that. So it's negative 1/2 times 8. It gives me negative 4, and negative 4 plus 6 is indeed 2. And same thing with the other point, 2. If I bring in the 2 from this point, negative 1/2 times 2 is negative 1, and negative 1 plus 6 is 5. So I can see that this definitely hits the 2 points that I had on my table. So again, this is just one example. There's lots of ways to think about this, but ask yourself what would have to be true if the answer I get is correct. What would have to be true if the answer I get is correct? And one of the things that has to be true is your known points, right, they have to satisfy the equation you get. So once you get the equation, the points that you knew from the beginning have to make that equation true. In other words, it has to make both the left and right hand side the same.